Now to follow up on the introduction to a radian, we all learn to use degrees when measuring angles, but most science and engineering applications use radians. So as you just saw in the video, radians are an alternate way of measuring angles, or just the amount of turn. So we're very accustomed to this 360 degrees turn, but now we have to make sure that we understand what a radian is, in case instead of giving degrees, they actually tell us the radian. So, looking a little bit further at the relationship between degrees and radians. So, the arc measure of a central angle of the entire circle is 360 degrees, and the radian measure of the central angle of an entire circle is just simply 2 pi. So now, we are going to learn how to convert back and forth between radians and degrees. So here is a circle, and you can see this is starting point here, so 360 degrees all the way around would be 2 pi. So now, what if we only wanted to know half of that circle? Okay, so it says divide both sides by 2. So if I divide this by 2 and I divide this by 2, I'm going to get 180 degrees equals pi. So right here would be 180 degrees, and you can see that pi is right there. So that is pi radians. Now, if we want to do quarters, we would divide both sides by 4. So we're going to get 90 degrees equals pi over 2. So if you look, here is pi over 2. That's because it's sitting at the 90 degree mark. And then here, if we divide both sides by 360, something interesting is going to happen. So this is going to be 1 degree equals pi over 180 degrees. So this is going to be very important because this is now a conversion factor. Now if I go the other way and I divide by 2 pi on both sides, I'm going to get 180 divided by pi equals 1 radian. So that is also important. So now we have them broken down into ones. So 1 degree is pi divided by 180, and 1 radian is 180 divided by pi. So now, if we look at how to convert from degrees to radians, we simply are going to multiply by pi over 180 degrees. So, question 9 says convert 35 degrees to radians. So 35 degrees times this conversion factor, pi over 180 degrees. Now, how are you going to remember pi over 180? Well, remember that we always want units to cancel out diagonally. So for those to cancel out diagonally, they need to be across from each other, diagonal. So then we can just simply multiply straight across. Now, if we do this on a calculator, it's going to tell me all of those decimals, and we want to keep things exact. So what we actually do is we actually just say 35 divided by 180. We don't want that nasty decimal. So we're just basically going to reduce that fraction down. So 35 and 180 will have a 5 in common. And it reduces down to 7 over 36, and the pi is right there. So we don't actually use decimals. Everything has to be in terms of pi. So now looking at number 10, 135 degrees, I'm going to multiply by pi over 180 degrees. Remember, we want these degrees to cancel out. I'm going to use the calculator to help me reduce that fraction down. So that's 3/4. So this is going to be 3/4 with the pi here. Now, converting from radians to degrees, we're going to use this conversion factor. So here we're going to multiply by 180 divided by pi. Now remember, we want the pi's to cancel out here. So here we have 7 pi over 6 times 180 over pi. So you're going to remember this because we want the pi's to be diagonal. Now we can use the calculator. 7 times 180 and divide that by 6. and we get 210. Now what that means, because this is now degrees, this means that this is 210 degrees. Now this next one, notice the pi is not there and we have decimals. So this one we're just going to keep in decimals. We're still going to multiply by 180 over pi. The calculator will do the work for us. So we're going to have 2.8 times 180 divided by pi. Use that pi key. And we're going to get approximately 160.4 degrees. So if you are converting from degrees to radians, you're going to multiply by pi over 180 degrees. And if you're multiplying radians, if you want to go radians to degrees, you want the 180 on top and the pi to be on the bottom. Now, we need to talk about arc length in dealing with radians. Now, this is going to be the same as the proportion that we looked at in the previous lesson. So remember, we have this proportion, part, which is the arc length, over the whole, which is the circumference of 2 pi r. So we're going to label this part, we're going to label this whole, and remember this right here is still distance in linear units. So it's just the circumference. Now, over here, we now have something new. This is not going to be degrees, it's going to be radians. Now, the whole, you have to know we don't use 360 anymore, we use 2 pi. Remember, 2 pi is that complete turn of a circle. And we go to the Greek letter theta for now this right here. This is the part. So this is the radian. So theta is going to represent that. So that's the part of the radian to the whole radians. Now, remember this side now, in the previous lesson I wrote down degrees. Now everything will be in radians. So if we look at, we're going to go to 14 instead of 13 since we're here. It says find the length of the indicated arc. So that's going to be the arc in bold. Now notice this turn, how we know it's in radians, the degrees now gone. This right here is now expressed as a radian. Therefore we have to do this proportion. So we are going to do arc length, which is the bold part, circumference 2 pi r, r is 16, equals the radian 3 halves pi over 2 pi. Now the quickest way to solve this problem, these 2 pi's right here will just simply go away. So I can go ahead and just get rid of those. Now if I cross multiply, I have 2l equals 3 halves times 32 pi if I put these together. So now I have 2l equals, now 3 halves times 32, we can do that without a calculator if we just divide 2 into 32, but if you don't feel comfortable doing that, then you can just say 3 halves times 32, keep that pi in pi form, so that's going to be 48. So 48 pi, divide by 2, so L is going to be 24 pi. Now, this did not tell me to find it in exact form, but if it did, that would be a plausible answer. But now that we have 24 pi, we can simply type that in on the calculator. So L is approximately 75.4 feet as a decimal, or 24 pi feet as an exact answer. So there's a couple of shortcuts you can take, but just remember you're just doing everything we did in the previous lesson. You just have to know how to deal with the radians now. Now let's go ahead and do this next one. He says a dog has a 20-foot leash attached to the corner of a garage. So like here and here and here. And it says when the dog pulls the leash tight, it walks from the fence to the garage. So notice that it's making an arc. It says it's 58.5 feet when it walks from the fence to the garage. It's asking what is the measure of angle theta, which is this angle between the garage and the fence, in radians. In radians. So here it's asking us to find theta. So we're not going to do anything with degrees. It has to be radians. So again, we are going to rely on our proportion. They told us the arc length was 55.8 feet. The circumference of this will be using the 20-foot leash, so that would be the radius here. So 2 pi times 20 feet, so that's there, equals theta, which is what we're looking for, over the whole revolution of 2 pi. Now, the feet will cancel out here, okay? So from here, we can simply just cross multiply. So we are going to say 55.8 times 2 pi divided by, that's going to be 40 pi. And remember, you have to put parentheses around that. Otherwise, it will not do order of operations. So I'm getting theta equals approximately 2.79. So it says, what is the measure of angle theta? It's 2.79 radians. It's not degrees. So if you rely on your proportion of part whole, and you know that there's 2 pi radians in a circle, it's exactly what we did yesterday, except with radians instead of degrees.